Hello, good afternoon, everyone. Can you hear me?
Yes, I hear you, sir. Afternoon, sir.
Okay, afternoon. Thank you very much. Okay, someone wanted manual attendance. Let me note down. Okay, thank you. And today is actually going to be our last lectures before we wrap up. And today we're going to cover 2 learning unit. And I believe all of you have already watched the lecture video, and you have an idea about what we're going to talk about today. And let me get started. Okay, hang on. All right, today we're going to focus on some highlights on this particular layer, which is layer 4. I think before this, we have been discussing from layer 1 to layer 2, where layer 1 and layer 2, we have a lot of material that's being covered because I think the first 2 layers are actually the most complicated, the most sophisticated. Then when you go up the layer to layer 3, and a lot of times we only concern about the internet. The internet is the most popular internet protocol. So when we come to layer 3, we only cover one protocol, which is the internet protocol IP. And then when it comes to layer 4, it's the same thing because layer 3 and layer 4 are supposed to work closely together. Where TCP IP, when you ever heard about, always talk about TCP IP, this means TCP is on layer 4, IP is on layer 3. Now today we're going to talk about the layer 4, which is very much focused on TCP and another protocol, what we call UDP. Right? A lot of people talk about TCP IP, but in fact, they also refer to UDP. So UDP getting more and more importance in today's context. And of course, again, in layer 4, we have a lot of other protocol as well, but just that in today's definition, in today's interest, a lot of other protocol in layer 4 are not as critical anymore. They are slowly being forgotten. So what is more important today in our network application is actually very much running on TCP and UDP. That's why for this transport layer, which is at layer 4, we're going to talk about specifically on TCP and UDP, which is actually a process-to-process delivery. So what does it mean? Okay. Oh, now let me turn on the chat so that I can see. All right, so for this process-to-process delivery, as we all understand, our application, our computers is just one computers, but our computer is so capable they can do a lot of things, right? So when you actually browse the internet, you can also, receiving your email. See, when you are browsing your internet using a web browser, you can also listen to your song over the internet. You can even watching a movie. Okay? You can even access checking your email, all happening at the same time. How could that be possible? Okay, only one computer, but you can have so many different services running together. Okay, so each of these services is actually called a process. So our computer is actually very much capable of doing multiple things all at the same time. So that's why we will have a lot of process running in our computers. If your computer is a server, okay, a server can be any computers lah. It is basically the different type of software that you are running, different type of application that you are running that make it being called a server. Okay, so to be honest, a server is just an ordinary computer system. Of course, a more powerful one. If you want to have more powerful server, of course, you're going to buy a more powerful hardware to act as a server, a more powerful computer hardware to act as a server. Right. So the process is basically the software application, and then they can create multiple process that is essentially for different purposes. And then each of these process is actually dedicated for one type of service, right? So maybe at this moment, it is still quite abstract. But when we actually look at the detail, you can see, okay, when we actually, let me enable my pen. Okay, so when we actually, sending our data in the layer 1 and layer 2, so what you have is actually all this, the router, the cable, okay, interconnecting each others. So when you actually go beyond, when you come to the computer itself, when your data actually reaching the computer itself, so your computer is running a lot of software. So all the software is going to pump data packets into the network, right? So different software is going to use different ports. So when we talk about process to process delivery, it is basically software to software talking to each other. Your computer software, this is higher level network software talking to each other. So they have to talking using the right protocol. Again, for one computer software to talk to another computer software, it has to be using the same protocol, same type of protocol, so that they can exchange of information. And again, different type of software that you're running on the same computer, they will create different type of process, different type of processes, and each of these processes will talking to the processes. For example, if you have an email client, you know what's an email client? For example, your Outlook is an email client. So when you're checking your mail, your Outlook is a process. Okay, so you're actually talking to the email server. So the email server is all using the same protocol, the same type of address to actually exchange of information. Then later you want to connect to a Telnet server or maybe an FTP server. Okay, so these are actually all using different type of these are all actually involving different type of process, and then they are going to use different type of address. So address in the software here we actually call it port, especially in layer 4 we call it port. You remember in layer number 3 we call it IP address, right? And then in layer number 2 we call it the physical address, MAC address, right? Okay, so in layer 4 there's a new name for addresses at this particular layer. This means at different layer the address has got different name. So in this case here, we actually call it port, P-O-R-T, port. This means different process will be using different port. So port is actually the address for that particular process. So your email will be using the email's port number. Okay, so each of the port will have come with different number. So different number represent different type of services and different type of processes. So if you look at this diagram here, so when you have a server, this is your server. Okay, your server is running different services. So you will have, you can see from this diagram here, you will have 3 blue color ports, and then this means this server running 3 different type of software, okay? Different type of software services. So a client is actually your computer. User computer is called a client host. So your computer is actually connecting to a particular port, okay, at the server. For example, these are actually 3 different ports, so there will be 3 different numbers, right? So different client, different computer in the network can actually connect to different services, can also connect to the same services as well. Okay, so that's why you have to differentiate between what is a server host and a client host. Server host is the one provides service. So for example, your email server, your web server, so those are actually server hosts because they serve you. Okay, they provide you with information, you send your request. So where are you going to send your request to? It's really through the service port, right? Through the service port of the server. Give you one simple example. You like to browse the internet. The internet is also using you want to browse the internet for web pages. You want to visit a website. So here's a web server, for example, www.unimas.ny. So when you go to this website, here is actually a web page. So it's a website. So when you're connecting to this particular server, you're actually connecting to a standard port at the server. For that purpose of web hosting, and they are using port 80. So your browser will be connecting to port 80. So when you are downloading a file, let's say you download a file from, dunamis.my website, which is a server, then you will be using a different port because FTP running on port 21. So your computers will be establishing another connection to the same server, but this time is running on a different port number, port 21. This means port number is just an address at this particular layer, at this layer 4. Remember, every layer has got their own naming convention for their unique addresses. So at layer 4, we use the term port, right? Okay. So when you look at the responsibility of the transport layers here, they actually do multiple things. A lot of things that has been happening. For example, packetizing. They put your program into different packets, which is what we call different segments. So they break your user data into different segments. So your data is being broken into different segments, all happening from this layer already. But I think if you can recall, at the data link layer, you also have packetizing, right? Yes, correct. So this packetizing here refer to the packetizing process happening at layer 4. And at layer 2, there is another similar process. Okay? It's another similar process. That's why I would say each of the layer is by itself. So it can have the packetizing, it can have the addressing, their own address, their own way of packetizing, only at their own layer. But when these packets being passed down to data layer, they are going to be packetized one more time, you see. Because as your data going through different layers, different type of treatment will be happening, different type of treatment will be given to your data packet. You first getting the treatment at layer 4, then later you go to layer 3, packet again, layer 2, packet again, then layer 1. Okay? So the packetizing is always happening, it's just a different method happening at the different layer. And then, of course, they also do the connection control. They also do addressing, which is actually the port number. And then they also provide reliability, right, to make sure that there is an end-to-end reliability. From this computer sending to another computers, there is nothing going wrong. If there's something going wrong, this layer can also initiate a retransmission. Right. And then in terms of connection control, they are actually having two types of connection. One is actually connection oriented. The other one is actually connectionless. So based on our experience that you all understand connection oriented is actually you have to establish a connection first before you can actually sending data. So you must first establish the connection. For example, remember, you have to dial the number, the other side must be ready to answer your connection request. And only you can establish the connection. If the other side didn't pick up, then your connection will not be able to establish. And another method is actually using connectionless. So you can see from here, one is connection oriented, the other one is connectionless. So when we are using connectionless, this means you don't have to wait for your recipient to be ready before you actually send your data. And these two different types of connection control method actually being represented by two different protocols. One is actually TCP, the other one is UDP. So you always remember TCP is the one that is connection oriented, which requires the computers to establish the connection first before they can actually transmit data. Okay, connectionless, you don't have to because they are using UDP. The nature of UDP is just keep sending to the destination without the need to worry about whether the destination is ready or not. It is something like when you watch YouTube, you can skip some of the scene and you don't mind, you see. You don't mind if you watch a movie over YouTube, a certain, maybe a few seconds of scene got lost. Do you mind? You don't mind. You don't even notice, you see. So that kind of application, we are normally using UDP, which is actually a connectionless control. And of course, addressing, as what I said before this. So when we have a connection, for example, if you are using the HTTP protocol, then you are using port 80. And if you are using the DNS services, you are using port 53. So if you are using FTP, then you're going to have port 21, right? So all these things happening. At this layer, they all go by the port number. port 53 for DNS, port 80 for HTTP, which is actually a website, a standard for the website. And then later we look into the reliability, because this layer also responsible for reliability of the sending of the data packet. So to ensure reliability, they need to be able to control the flow. They need to be able to fight the error. Okay? So at the end of the day, at the transport perspective, there is an end-to-end transport that is being established under this layer. Okay, let's look at the internet transport layer. Okay, as I mentioned to you, there are many other different types of protocol exist in layer number 4, but they are just not so important now today. So what is important today is actually the internet. So that's why people put a lot of study, a lot of attention to the internet. So in the internet here, we actually support 2 transport layer protocol. One is called the TCP, the Transmission Control Protocol, which is aiming for reliable, reliable services. And the other one is an unreliable user datagram protocol. So it's called the UDP. This one is unreliable, meaning to say, if you can afford to lose some data, okay, in the transmission, and you don't mind those data being lost, because it doesn't affect you much, that's why you can use UDP. Obviously, UDP is going to be faster because it doesn't require a two-way handshaking to establish the connection first before you can send your data. So UDP can just connect and send. So because you don't care, right? So there's an application. Most of the application of the UDP is actually on video, real-time audio, real-time video, okay? And then video streaming. Okay? So they're usually using UDP, okay? User datagram. And as compared to TCP, which is actually much more reliable. If you want to do online banking, if you do all the HTTP, then this is actually the TCP protocol that we are using most of the time. Last time, long times ago, I mean, sending video over the internet is not so common. It's not so common, owing to that our internet is actually slow. But today we have a different story, because our home internet now getting as fast as we can afford. See, we can go up to 800 megabit per second or even 1 gigabit per second. And because of that, that's why the UDP, the user datagram protocol, has become more and more important because of a lot of people delivering real-time traffic such as audio, video, okay? And then I don't want to talk about gaming because I think gaming you will need TCP. See? Maybe the video for the gaming, they are using UDP. So these are actually the 2 protocols that we're going to study in this learning unit. Okay, so I think these are standard stuff. So let's look at the port numbers. So each of the computer will have an IP address. Okay, this is the IP address. And then each of the service running on this computer will have a port number. It's not limited to 1. You can have multiple. You can have as many as it is available. Okay, so let's say, for example, the IP, this computer is actually, the IP address is actually 200.23.56.8. Then the port number for the service that it is running is actually running on port 69. So you can actually create a socket address by using the IP address and the port number. Okay? This is how they actually write it. Okay, so this is what actually happened. So see, the data is being transferred between the 2 computers. This is 1 computer. This is another one. Okay? Between 2 computers here by using the transport layer. What you see on the transport layer is that you will see your data. Okay? It's all go according to the destination. Okay? Go to the destination port number. Okay, so the process to process delivery will need an IP address and port number. Otherwise, this thing cannot happen. I know your computer can run multiple, but you have to differentiate them. You still have to differentiate them. This is how you differentiate them, by using different port number. Even though the IP address is the same, the IP address can be the same, but you are using different port number. And in terms of port number, so what are the port number that we can use? Is actually the first 1,000. You see, the first 1,000 are the well-known port number for some of the well-known services. Right, for example, FTP, Telnet, SNMP, HTTP, they are all the different type of services can be offered by the same machine. And why the first 1000? But here mentioned 1024. Or sorry, to be precise, it's actually until 1023. It's not until 1024. It's 1000 is 1024. 1000 kilogram is 1000 gram. But 1 kilobyte is not 1 kilobyte. It's actually 1024 bytes. Huh? So these are the things that a lot of people get confused. Okay, now let me show you the different port number that is associated to a different type of protocol, as well as the different type of services. So you can port 7, 9, 11, 17 quad. Okay, and then 53 is name server. Name server is very important. It's what we call the DNS, domain name service. So without this name server running at port 53, then you may not be able to browse your website, okay, because no one can do the translation for you. What you can remember is only the English light that of address, isn't it? But actually the entire computer world, computer network is actually operate based on IP address. So you need to have someone to do the translation between the two, between the name, between the request from the user and the destination, which is actually the name server play as a translator. Okay, so these are actually some of the popular ones that has been used. I'm not going to show you all of them. You can easily search this information from the internet. But some of the things that we usually use is like FTP data, FTP control, Telnet, SNMP for email. DNS is for sure. DNS domain name service is for sure for all the computers to be on the internet. Because the domain name server is basically translating your request. So translate your request so that the computer can understand what you want, and then later they will actually carry out the task as you required. And if you look at the error control here, error control is actually a very crucial element here as well. And as if you can recall properly, at layer 2, at layer 2, we have a lot of error control mechanism already. So then why do we still need to have error control at the transport layer? Is it redundant? No, it is not. So if you look at this diagram here, you look at this black color stick here, this is actually cannot be verified. Okay? The error control cannot be verified by the low layer data link. This one going up to layer 3 and layer 4 already. And then this is a router. As you can see what I'm drawing, this is router, and then this is the router. So the router only until layer 3. Okay? But they will still need flow control, error control as well. Okay, and because of computers can run multiple processes, and then different multiple processes will create different data of port. And then when you actually send data out, you can people has been making use of multiplexing as one of the important process that will actually help you to multiplex, so that using one channel you can have multiple user data going through at the same time. All right, now let's look at the details of UDP. The user datagram protocol is called a connectionless. Remember, it is actually a connectionless. You don't have to establish any connection before you sending your data. You just send only into the internet, and hopefully the data will actually find its destination. And this type of protocol usually is less reliable, okay, because you allow the packets to actually simply go anywhere. So this is actually, exactly for the reading. And then, of course, each of the UDP port, they're also having what we call the queuing system to queue incoming data packets. Okay? And then when you send something out into the internet to someone else in the internet, then using UDP, then there will also be incoming queue. The queue going into the client. So queue is there. So UDP application, if we look at it, it is actually the type of application that can tolerate a small amount of packet loss. A little applicable loss will not kill you. But if you are sending a file, okay, for example, a document file to your friend, and then the network is using UDP, then most likely when your friend open up, then your friend will see that, hey, how come there are some empty pages, nothing written there? It is actually not nothing written there. It's just that this data is not being lost. You see. So only those type of data that can be lost and then you don't notice it, such as movie, streaming movie, streaming audio, or even live conversation over the phone. So these are actually happening. So you can see that when you are using UDP, your application probably can tolerate a small amount of packet loss. And then some example are multimedia application, internet telephony. You can see the name multimedia, internet, real-time video conferencing, and then also domain name system. So when you're actually sending your URL from your web browser all the way for the translation to get up, so your request will be first sent to a domain name system, DNS server. So this domain name system is going to look through your address and then to see, what does it translate into? What are the IP address behind the scene? Machine is using IP address. In fact, the entire internet is actually using IP address. But because we are all human beings, so we cannot run on IP address. We will not be able to understand. I give you a series of numbers, just a number, it's not meaningful, just numbers. But you cannot tell from the number, what they are, because you do not have the tools to decode the entire data packet. Then because of that, we need a domain name system to do the translation for us. Every time when you type in an address, for example, www.unimas.my, so this domain name system is going to help you to translate and then convert them into IP address so that data can flow through the IP connection. So domain name system is basically a translator. Okay. So UDP also cover audio, also cover routing protocol. So these are actually quite common. That's why you have to understand the nature of what is UDP and then where it can be used. And now we study a little bit about the user datagram format. You can see that they consist of two parts. One is actually the header. The other one is actually the data. So inside the header here, you will have the source port number, okay, the source port number, the destination port number, and then the total length, and this is actually the checksum. Okay? So you can see that this UDP one is actually pretty standard, pretty straightforward. Right, the next one. The next one, what we have here is actually the TCP, which is what we call the Transmission Control Protocol. And again, it is a connection-oriented protocol. So when it comes to connection-oriented protocol, you always have to remember, you must establish the connection first before you can send them the data. So this TCP is actually a connection-oriented protocol. It creates a virtual connection between two PC to send data. So I can connect to you, you can connect to me, all at the same time, all happening at the same time. Okay? So this is TCP. And then it can actually uses flow and error control mechanism at the transport layer as well. So transmission control protocol. The transmission control protocol properties actually consists of the connection-oriented type of protocol and also reliable. And then usually they can establish two virtual connection, such as in a full duplex situation. Full duplex means you can send and transmit at the same time. So that's what we call full duplex. Okay, and then here are some of the description which I will not go through, but I just give you the important point on it. So which one is faster? And based on this based on what we have gone through. So which one is actually faster? So for your information, I think the UDP is going to be faster because UDP do not have to go through so many type of connection establishment. So when you arrive there, the guy will just cut it. See? Oh, okay. So these are the things. Right. So connection oriented, usually they are slower. When you watch a real-time video, real-time audio, and you do not want the protocol to slow you down. See? That's why I would say last time, during my time, there was actually more than 20 years ago. And when we use the internet, we do not have a lot of application. Okay, we do not have a lot of real-time applications such as video conferencing live or watching video streaming. So we don't have such things. That's why this connection-oriented essentially means quite good already, because you can establish connection to your client, and at the same time, connect to your client, and then you can send data across. And anything connection-oriented will always involve a three-way handshaking. Okay? You can see from here, this is actually a three-way handshaking connection. Why three-way? The first one is, of course, establish the connection. Send request to establish the connection. Second one, the other person will have to reply to you. Okay? Reply, okay? And then to close it. So there are three ways to actually, there are three ways for the data to actually being transferred. Three ways process is required. So you will have the setup, data, delivery, and close down the connection. Okay. And this is just a diagram illustrating that when A and B, host A and host B would like to talk to each other. So what happened at layer 4? And the host A will send a connection request from A to B, and then B, if B is comfortable of accepting it, B will reply the acknowledgement. Oh, I sir. See? So they will actually respond. And of course, your computers, or what we call servers, will not run just a single application. Usually they run in multiple applications. So because of that, they have to use multiple different type of port. Okay. And then this TCP establish a virtual connection. Basically, because you want it to be connection oriented, so the connection must be there. So TCP, they will establish a connection first before they send any data over. So they have to get ready the environment. And full duplex, whether your connection is full duplex or half duplex, that is very much depending on your equipment and manufacturer to see what kind of hardware you are buying. Some of the hardware just support full duplex, some of the hardware are not. Okay, so data segment, okay, that is being broken down. We call them data segment. They can flow into both the direction at the same time. And usually under TCP protocol, there are two virtual connections are being established. One is for sending, the other one is for receiving. Okay, this is all about the flow control. Flow control is actually to regulate the traffic. If it is too fast, you need to slow it down. If it is too slow, you can fasten it up. So there's the whole idea of flow control in this particular layer. Okay, some of the TCP application. For example, you want to do data transfer through TCP, you can use the World Wide Web using HTTP. And you can use the electronic mail as well, Telnet, all the file transfer using FTP. So those are all the TCP application. So now you look at the frame format, the segment format. We don't call it frame. Frame is actually in layer 2, and here we call it segment. So you can see they consist of two segments. One is actually the header, the other one is actually the data. And if you look at the content of the header here, it's actually much more complicated because you have to include the sequence number, okay, acknowledgement number, and so on, okay, for you to have a successful connection. All right, this learning unit is actually short because we just covers TCP and we get the different application scenario of the TCP. Always remember, TCP will give you reliability when you do online banking, when you browse the internet, when you're downloading file. Okay, I'm not talking about streaming music. It's different. I'm just downloading file. So those are all four under the most of the time they are using they are using TCP. Okay? And as for UDP, they aim for UDP. They aim for real-time application where you need the traffic to be exchanged soon as possible. You don't want to do handshaking, something like three-way handshaking before you can send. So you just open and send for the UDP. Because what? Because if you open and send, then there might be some chances that your item is going to be broken, lacking, your data going to be lacking, which is actually lost along the way. So can your application tolerate that kind of loss? If you can, then you can go for UDP. Right? So this is actually a two different protocol that is actually very, very commonly used in our day-to-day internet application. And again, they come with, is there any, where is that? I have the number instead. Oh yeah, if you look at this, okay, if you look at this diagram here, there's actually a longer one. So this diagram will show you different type of services will use different type of port. These are actually based on fixed one. So if you want to use your own port, you may ask, can I use my own port numbers for my website? If I install a web server on my computer, for example, you install Apache or you enable your Internet Information Server from Microsoft. Okay, so you can actually use your computer to act as a server. Of course, a low power one. You might not be able to serve a huge amount of users. Right? So you're going to ask yourself, see, some of these, are you going to using what port? And some of these port, the port number has been fixed. Especially the one within the first 1024, the port number are very much fixed. So you cannot simply change them. But again, if you do not like those port number, for example, look at this one. There's no port. See, you look at this one. Okay. HTTP is actually 80, using port 80. So port 80 is by default, all the web server will be running at port 80 by default. So, but if you are developing your own system and you want to host your own web application using your own computers, you basically treat your computers and then turn it into a server. Then you can use a different port. For example, some people use 8080, okay, as the port for their application. Some people using 9000, okay, some people using 8000. So it's up to you. As long as you don't touch anything that is below 1000. Below 1000 is some kind of standard that people fix already. Okay, but if you don't like 80, you can always reconfigure your web server to make it listen to other port that you like. But the default one is 80, like you don't even need to specify anything, and you will be able to access to what we call the HTTP traffic. Okay, I hope this is straightforward. So here we just have a different name for the address. We call it port. In fact, UDP is very important because this has been used in our DNS service. Our DNS service has to be highly reliable. Okay? If your DNS is down, then no one can access the internet. Even the connection is there, you will not be able to access the internet. So that is actually the issue. Okay, so is there any questions? Is there any question that you would like to highlight? You okay? So if you're okay, then I will just proceed to our next learning unit. which is actually, we are going to look at the highest layer so far, which is actually what we call the application layer. We have 4 layers underneath already, right? Layer 1, physical. Layer 2, data link. Layer 3, internet protocol. Layer 4 is actually our transmission, our transmission control protocol. And then now we go into the application layer. Application layer, as the name implies, you know it is actually meant for your software application, the one that you can see, okay, on your own Windows. Okay, for example, your browser, okay, your internet browser. You know what's a browser? Your internet browser, like your Chrome, like your Firefox, okay, Microsoft Edge. So they are all different clients, but they do keep information there. So let's say application layer here, we look at all the network applications. Okay, so sorry, I haven't shared. Sorry. You probably do not see my screen, sorry. Again, I made this silly mistake again, talking to myself. Okay, here we go. Okay, network application. So let's look at what we have. So it's very much software programs that you can see, that you can interact with. Example of network application, your web browser, like your Chrome, your Firefox, your Microsoft Edge. So those are network application. Your Outlook mail client is a network application. Okay, so those are actually network application sitting in this layer. And in terms of software, now we're talking about software. Okay, the user can interact. You can actually check your mail. You can actually, you're using your web browser to go to any website you like. But all of these applications are actually based on different type of architecture. For example, we have host-based architecture, we have client-based architecture, what is client-server, and what is peer-to-peer, okay, and so on. So again, if we can see, application layer is all the applications sit there. And of course, in your computer, you have many applications. Some of the applications are actually not network. For example, your Notepad, right? Your Notepad is not considered as a network application because it do not have the ability to interact with the lower layer, such as transport layer. Okay, so your email is a different story. Your email will have a dedicated port, okay, on the transport layer, and your web as well. Your word processing now slowly they are having all these. Last time, your word processing is like your Microsoft Office. They are very much a standalone application, but now today they are going for cloud-based, so that you don't really have to download and install before you can actually use them. So always remember, application layer is all the different applications like email, web, word processing, Excel, MP3 player, and all the stuff. These are all in the application layer. But only the software that has got the network capability can be placed under the application layer. Because your application layer still need to interact with your transport layer anyhow. Okay? So if you do not have those, then how are you going to, you just stand alone, so you cannot categorize yourself as a network, as an application layer. And at the application layer, even though we're running software, but our software can be categorized into 4 different categories. 4 different functional category. So the first one is data storage. Okay, whatever that you have to have a place to store your data. For example, a website. A website is hosting a lot of information. So when the user browsing through different websites, then they will be able to get their information. So this kind of server will have huge databases. And then another one is actually the data process, the data access logic. It's actually the, processing the required to access stored data. So your data access logic. So you define the logic. For example, your SQL server. Okay, your SQL is actually named SQL. Your SQL server, SQL server. So it's actually belong to the data access logic. So it will help you to manage your large amount of data. They help you to manage. And the third one is application logic, which is actually the business logic, the intelligent. That's why I say software, you think software is so clever. Software is clever because they have very good application logic, meaning to say their business logic, okay, how this application work and all those things. So these are all the application logic. And the last one is actually the presentation logic. And in this presentation logic here, you are just basically doing presentation, you know, what you can see on the screen, right? What you can see on the screen. As straightforward as that. So, and we're going to look into each of these detail. We have, generally we have three different types: host-based architecture. So the server will actually basically perform all the functionality. And now we have a client-based architecture. Okay, hang on. We have client-based architecture, we have host-based architecture, and we have client-server architecture. So these are actually defining how each of the software interact with each other. You have two computers. Okay, you have two computers here. Now you want to access information. So how do you make it feasible? Right. So these are all based on the different architecture that we are studying here. So you can, if you are software developer, software programmers, you can actually engage different type of architecture so that your program fit in well, you see. So this is actually high level. We talk about applications architecture, how you design your software. Okay, let's look at host-based architecture. So what's the difference? Host-based. Host-based already tell you that, you know, the host is going to be busy. Host-based architecture. So in a host-based architecture, this is the client, and then this is the server. So the server will probably almost full after you put in this application. And you can see that under the host-based architecture, the host here refer to the server. The host here is referred to the server. And then you can see this kind of host-based architecture, the four logic, including the storage, is all managed by the server. So your client will have not much to do because you see all the logic actually require all the processing power. So your client is actually very thin, very lightweight because you don't have to run a lot of application. Okay, so these are some of the things. And one of the example here is actually VNC. I do not know whether you have been using VNC or not, but I also do not know whether you are using a remote desktop or not. So VNC is very much like a Linux-based kind of. You can use it on the Windows as well. So VNC protocol allow you to exchange of information based on the host-based, based on the host-based architecture. Basically, when you actually connected to the VNC server using your own VNC viewer, then your server will have to work harder. And another example, okay, when we talk about VNC is very much from the open source platform. But now we're talking about Microsoft Windows, and you guys like Windows so much, isn't it? So there is also a similar application of similar function. It's called the remote desktop. Right. So remote desktop works exactly the same as the VNC. It's just that, you know, the server will actually keep all the functionality. Will actually perform all the functionality. They will not leave anything to the VNC viewer or to the client so that they can go and download this and that. No need. So this is the client-based architecture. You can see here, I think I want you to see here is actually, see, a client-based, the name client. Client is this guy. Okay, so client-based architecture, most of the time, is the client performing all the presentation logic, application logic, and data access logic. So only the database is hosted in the server. So this is client-based architecture. Each of them will come in pro and cons. So you have to understand each of them will come in pro and cons. Because they come in pro and cons, so you need to be well aware of under what kind of situation you have to engage which type of architecture. And this is the client-server architecture, meaning to say we share lah. Okay, you take half, I take half. Right? So this is actually a client server architecture. For example, in this case here, this client here, he has to be responsible for the processing logic and the application logic. So the server will do the application logic, data access logic, and the data storage. So we just split the task in a client server architecture. In a host architecture, your server is, everyone rely on your server. So your server is going to be a lot of times, running at the high, running at heavy traffic, a lot of performance degradation as well. But you run it on a client architecture. So, a lot of things also do not have. So they basically just split. So the server is going to host the data through SQL, and then they will also have to define a data access logic and application logic as well, so that they will work together with the client PC in a client server architecture. So share basically we share. So you don't put a pen on one person. So now you can look at the advantages and the disadvantages of the software itself. I think this part is actually pretty much standard. I think you can look through this yourself. When you are being asked to actually choose, so you must know the advantage and disadvantage of different architecture. There's no one perfect architecture. Okay? No one perfect architecture that you are having. But you can choose based on your scenario, based on your situations, to see which architecture fits you better. Okay? That's why they will come with advantages and disadvantages that you will have to go through. And sometimes when we have multiple server applications running at the same time, then not all the clients manufactured by different manufacturer will be able to, communicate with a different server application program. So in order to reduce that, and a middleware has been introduced to actually act like a translator, act like a translator for your network application architecture, so that all the clients can connect to the server. This is the client, and all these clients actually built by different manufacturer, and then they may not necessarily be able to talk to the server component. All right, so there will be also multi-tier. Multi-tier means more than, it's actually more tier that is being introduced. So for example, a 2-tier architecture where the client and the server are in balance, very popular. 3-tier, so you actually, each of the tier will involving a computer system. So the more tier you have, the more computer system will involve in forming the entire, service. So we have N-tier architecture that involving maybe 4 or 5 server. Right. So let's look at the diagram for us to understand them better. So this is actually an example of a 3-tier network. So you have your presentation logic sitting at the client, application logic sitting at your application server, and then the last server is actually your data access logic as well as your data storage. Right? So this is how they share the load. When different tier will take over different functionality. And this is actually an N-tier architecture. If you look at this one involving 4 computers, the client is obvious, presentation logic, but you will have a web server here, and this web server in charge of application logic, and then you have an application server. So this application server will in charge of application logic. And lastly, you will have a database server, and this database server is in charge of data storage, at the same time, data access logic. So this is this N-tier. And of course, there are pros and cons of this N-tier architecture. Let's look at the advantages. It can achieve better load balancing, because you will have more than one computer. So your load is not going to be just pushed to one computer alone, but you can load balance among all the N-tier computers that you have under the same setup. And then they are also much more scalable. Only the server experiencing high demands needs to be upgraded. Okay, so the administrator can easily take out and put in new server resources. And so what are the disadvantages here? So you could actually produce a lot of traffic, you see, because you will have so many parties to actually talk to because of that. So the network traffic is going to be heavy after this. Okay, after you have establishing all this. And then difficult to program as well because you're involving multiple tiers. So your program will have to sit in different computers, and at the same time, you have to make sure that they can actually talk to each other. So if you want to test this kind of N-tier architecture, so it is going to be very difficult. Very tedious. It's not to say cannot be done, but it's just very tedious. All right, so we have two different types of client. Clients means what? Your user computer is called client, you see. Server is usually belongs to one organization. It's trying to serve their customer. For example, you want to put up a website. Okay, you can put up your own website. Okay, hosting your own website on your own web server. So there's no problem. But when it comes to the client, it's actually talking about the user computer that is being used to access the information. So we have thin client and thick clients. From the name, I think you can tell. Thin client are actually very much thin, skinny, thin, not much meat. So they have less information. They will have less functionality as well inside a thin client. And then thick client are actually the client that has a lot of functionality. Okay, so for example, your application logic and things like that will all emphasize into a thick client. So thick client will serve more functionality. It will actually serve more functionality, such as it will actually serve more application logic as well. Thin client do not have to, because thin client was designed for lightweight. All right, so this is actually an example of thin client example on a web architecture. Web architecture, your web server. I hope you know what is a web server. Your HTTP server is actually a web server. Okay, Unimas.my is a powered by a web server as well. So you go to www.google.com. Google also got a web server. And then your computers is actually the client or the PC. So most of the time under thin client, your computers were only doing presentation logic and all the other logic being done by the server. And we have peer-to-peer architecture as well. Instead of we just want to do splitting tasks, then we can have these peer-to-peer architectures where all computers can serve as a client and server at the same time. Your computer can be a client, can be a server, all at the same time. I do not know whether you ever download files from the internet using BitTorrent. So if you ever download movie using BitTorrent, then you will understand what we are talking about here. Those are actually peer-to-peer. Here is no fixed server. It's just actually pool of users sharing the same interest. They gather together. So when you actually download a file, you can download it from multiple users. Okay, so this is usually a peer-to-peer. And last time we used to have a music player, or what we call the music website, called Napster. That was back in the year 2000 or 2001 or even 2002. It's about 20 years ago. So Napster was quite popular because you can just listen to music through Napster without the need to pay for a single cent. But Napster later on got sued. Okay, it got sued. That's why Napster closed shop, I think. But a lot of illegal movie will still be shared through peer-to-peer services, through BitTorrent. So a lot of people are actually downloading because there is no fixed server. You have to understand, peer-to-peer means no fixed server. My computer is a client. Your computer is also a client. But your computer can act as a server. My computer can also act as a server. The moment when we are in the same group, then you can access my file. And you can even access the same copy of file from many different other computers at the same time. Right. So if you ever download a movie using things like BitTorrent, then you will be able to see the scenarios. And the advantage of it is actually the data can be stored anywhere on the network, so you don't have to worry about the server down, you see. if you have a movie, for example, and then a lot of people downloaded your movie using peer-to-peer, okay, P2P service. So if they do not switch off their computer, some of people come in and download, they will be downloading from multiple sites. See, that's why you can have a very fast download speed on the peer-to-peer architecture, such as BitTorrent, because it is actually more than one server, more than one computer is serving your download. They also keep a copy. After they downloaded, they keep a copy. They didn't remove the copy. So next time people want it, they can also send to them bit by bit. So they all add up to be very fast. So of course, another advantage would be it is actually very resilient to failure, because one computer is turned off, it will not affect the operation. You can still download, maybe at a slower speed. And the disadvantages is that finding data can be difficult. So if you don't know where exactly your data has been stored, and then of course there are some security concerns as well in a peer-to-peer architecture, because you are downloading from someone that you don't even know, you see, right? Because everyone can just install BitTorrent, and they've got file to share, they can put it inside there, and you do not know whether they are good guy or bad guy. You see, this is not an official website. Sometimes you don't even know where you are downloading this thing from who you downloaded these files and things like that. That's why there are some hidden security risks in this context. All right. So now it's come to the criteria for choosing an architecture. So which one is better for you? Okay, so what are your considerations? So these are three considerations here. One is actually the infrastructure cost. So how much do you willing to spend on infrastructure? For example, buying servers, okay, buying client computers, and buying the circuits, which is actually the network. So if you're using a mainframe, in your computer architecture, you probably will heard about mainframe. It is actually a server, let's put it this way. The older version of server is called mainframe, and then they are so huge, and you cannot just move them and put inside your house. Okay? So a mainframe during the time is very expensive, and then it comes with a lot of terminal. Okay? And then a lot of low power computers are actually not so expensive, because last time what they're doing is actually very simple. And then the second thing that you have to consider is actually the deployment cost. How much does it cost for you to deploy the software and so on. So deployment cost. And then another one is scalability. Now you want to start small, then later can you grow bigger? So how big can you grow? So those are actually the things that you really have to take into consideration when you're actually choosing an architecture for your software development. Here we talk about network application, okay, not any, you're writing an application called calculator. No, not that one. It's different. This is what we call when you write network application. So what are network application? Your web browsing, okay, your email, your FTP downloads, your DNS, and so those are actually the web applications. Example of a web application. Okay, so when choosing an architecture, so there's it's better to look at it from a table. So the criteria are actually three. I think we have just gone through these three. And then host base is actually based on most of the data, and processing logic is on the server, which is the host. And then the client base, so the processing will be a lot on the client itself, or a share model of client server. So everyone share a copy, so you will be okay. But you can look at this. The cost is high if you are doing host base under cost of infrastructure. So the cost is high for host base. And then for the cost of the development, it's actually low. Scalability also low. Okay, and then this one also low. So this table is just to give you a comparison of different type of architecture against different type of costing. And these are some of the example of the application layer. For example, your World Wide Web, this is actually accessible using your internet browser such as Chrome, Firefox, Safari, Microsoft Edge. So those are the common browser. Of course, it is not limited to the one that I just mentioned to you. We have Opera, we have Iridium, we have Brave, we have all sort of browser out there. Actually. Okay, you have Firefox. There's also a Waterfox. Okay, so these are actually all the web browser application allow you to access a web server over the World Wide Web. So this is actually the protocol. And email, you know that email, same thing. File transfer protocol. You can either use FTP or you can use HTTP. Also can help you to do file transfer. And you can do Telnet. You know what's a Telnet? Telnet is actually a remote station into a computer. Right. It's in a remote station. Usually this one is on a CLI, like command line interface. Also you use Telnet and it's actually quite useful. So you can Telnet into from one computer to another computer. So you can actually using the command line to carry out tasks. If you watch movies, I think a lot of hackers are actually using session like Telnet, okay, to actually hacking into other people's computer system. That's why I say the CLI interface is very flexible. You just need to type, you know the command, you need to type, and then your things will just run just like that. And of course, you have instant messaging, video conferencing, applications such as WebEx, such as Zoom, and we have webcasting as well. I think you see a lot over the YouTube live, so Facebook live, YouTube live, those are the webcasting and so on. So these are all the network application that resides in the OSI 7 layers application layer. So it's not any application will come into here, it's only the one with the network capability. Okay. For example, you are using a notepad or your calculator application, so those are not considered to be inside this layer. So in this layer, we talk about all the network applications on. All right. I think it's time for questions. I'm not going too fast because I have the lecture video that is actually ready for you in the website in our Ellipse. So I think that will actually help you. All right, so time for questions. Any questions so far for this layer 4 and layer 5? We are talking about the TCP/IP model. The TCP/IP model consists of only 5 layers. So I think these are the 5 very important layers in today's our context here. Today, everything, when you talk about networks, talk about, the internet, it's all about this 5-layer TCP/IP model. And again, some of the reminders about the projects. So I do not know how each of your group are actually seeing your group projects. So when you actually read the instruction, given inside the group projects document. So actually every piece of information given, they should serve some meaning that will have some influence to your design of your network. So I will need, because a lot of you are actually quite silent, I will really need each of the group to actually give me 2 questions. I would like to know what is the question in your mind. After you start working on your projects, what are the questions that bothering you? What are the questions that first pop out? I want you to put it inside our website. I actually created a forum. So I think each of the group can just post 2 questions that why that is important, because by looking at your question, they will be able to let me understand the way how you see the question, so that next time I can improve the question to make it better or maybe more challenging or maybe easier. I don't know. Yeah. So I think when your group starting the discussion, I'm sure you have some questions in your mind. I want to know the first 2 questions that come into your mind when you're actually doing your group discussion. So what are the questions that bothering you? it is not so straightforward, I believe. So I would like to see some of these questions. What do you see in this set of projects question here? And they will really be able to give me a better understanding from your perspective. Right? So maybe the group leader can do that. So I'm not asking a lot. I just want to know the moment when you start doing your project. So what are the questions after you're reading through the instructions? So what are the questions that pop into your mind? Is it clear enough, or is it you find a lot of redundancy or whatever? So some of these things, you just pause it there. Okay, let me have a look, because next time I can actually do a better projects. I think more challenging, more interesting one probably. Yeah. So okay, so that's all from me. If you don't have any questions, but anytime you have any question, I think we can always communicate again using our online forum. So I will pay a closer attention to our online forum in case you have any questions that you would like to ask, and when you prepare for your final exam, and also for your project as well. All right, so I think that's all for today. Any other question? If you don't have any questions, then I will share you the attendance again, so that you can. Oops, hang on. Gosh. Let me share again. Yeah, for some of you who haven't taken attendance, you can scan your attendance again. And one person asking for manual attendance, and I take notes on that. I think if you have done your attendance scanning, then you can leave. So we will see each other again in our online forums if there's anything that you would like to discuss. All right. I'll see you again. Bye bye, and have a nice day.
Thank you, sir.
Thank you. Bye bye.